Okay, in this episode we will implement a GraphQL server, but before we will actually start with the web layer, what I would like to do, I would like to start with the data and the service layers, so we will have a sense of a complete application in this episode. So what we will start, as always, we need to start with the model definitions. So let's go and let's create a new package, and let's call this package model, so it will contain model classes. So the model class that is used in this project is called employee, and it would be a record. So the first thing first, we need to provide a unique identifier, which will be type of UID. So we'll have a first name and the last name properties for this model. And as always, you know that I like to create a separate definition for the list, and it's called employee list. So here we will have only one property, which would be a list of employees. And now, as we have two models, now we could create a data layer. So let's create another package and let's call it data. So here what we will do, we will first create an interface definition and call it employee repository. So all methods that we'll have in repository and service layers actually will return a future type, so we will be able to incorporate them into reactive pipelines. So, and just to note here that we need to return future types from Vert.x core library, not from Java util reactive types. So the first one would be called create employee. So the second one would be called an update employee. The third one would be used in order to remove an employee, and in order to remove an employee, what we will have, we will pass an ID here. Then we need to have a method to retrieve one employee by its ID. So here we will return an optional type, so it's a good practice that we'll have an optional, so we'll be able to distinguish do we actually have a record or not. And we call it find employee by ID, and again we need to provide ID argument here. And the final method will return a list of all employees, so we will return an employee list type. So now let's provide the implementation here for this contract, and let's call it employee repository implementation. So what I'd like to do now, I would like to paste an implementation that I have already prepared. So just me check that everything is correct here, and as you could see, we use a library that is called Eclipse Collections. So let me quickly go to my browser, and you could see that I have this Eclipse Collections website. So basically this is a library that allows us to use a Fluent API on mutable and immutable collections. You could find documentation here under the reference guide. So here you will have this complete documentation of all methods that are provided and all APIs that is provided by this library. You could use actually any type of collections, such as Java collections framework, or you could use Guava collections. In this particular tutorial, we will not focus on databases. So if you are curious about using databases, I highly suggest you to check my another YouTube series about Hibernate, Reactive, and Vert.x. But here we will use just this in-memory collections in order to have some data, so we could play around with some repository methods. So now what we could do, we could go and let's create a final piece of the puzzle, and it will call the service layer. So on a service layer, we will have basically just the wrapping of a repository layer. So we'll call a class employee service, and it will be an interface. And what we will do here, we'll just provide same stuff that we have on the data layer. So basically, as you could see, what we will have here, we just provide same methods as we have on the data layer. And in our case, this service layer would be very simple, but it is not a reason to avoid using service layer, because service layer is basically a place where business logic of your application does live. So if you don't have it, and if your application is very simple, maybe you will not basically feel the necessity of the service layer, but when your application will grow and grow, you will need to provide a place for service logic, so the separate place to business logic of your application, and you will find yourself mixing all this logic inside web or data layer, which is not actually the best way to organize your code. So now let's provide an implementation for this service, and let's make a type of record, and let's call it employee service implementation. So it will have one dependency that is passed using a constructor-based dependency injection, and it will be employee repository type. And let's implement this employee service contract. So now what we will do, we will just wrap these methods with the repository that we have. So as you see, in our case, our service is very simple, and we just wrap in this service methods, we just wrap a data layer component methods. But again, as I have mentioned, it's not a reason to avoid a service layer, because using a service layer is a very important thing, especially with the perspective as your application will grow. You will definitely need a place to allocate the business logic of your application, and this is the place called a service layer. So now we will have a data and a service layer, and we could proceed with implementation of a GraphiQL logic. So let's see how we could do it. Okay, let's start with schema definition for our project. When it comes to GraphiQL, we use schemas in order to define types. And basically we have three types. The first one would be an object type, as you could see here. So object types. Basically object types are models which represent entities of your application. The second two types are queries and mutations. And as you remember from the previous episodes, queries and mutations basically equivalents of CRUD methods, so we use them in order to implement CRUD logic for the GraphQL application. So let me go back to my IntelliJ, and let me create another directory inside the main package, but would be a resources directory, because we will allocate here schemas. So let's create inside another directory and call it schemas. And now let me create a GraphQL file that's called employees GraphQL. So the first thing first, we need to provide a model definition, and we have one model that is called employee. So we call it type of employee, and here we need to provide three fields. The first one would be ID, and all of them, by the way, would be a type of string. However, what I'd like to do, I would like to pass here an exclamation mark, and that means that these two fields should be not null. So this last name and the first name should be not null. And it makes sense, because when we create a new employee, we don't have ID yet, because it is the field that's provided by a data layer. It will be generated on a data layer, but we still need to have a first name and last name in order to create an entity. So then let's go and let's create query definitions. So here we'll have two queries. So the first one we'll call all employees, and this method will just return a list of all employees, and unlike the methods that we have in the previous episodes, we will not have any arguments here such as pagination. We just will return a list of employees. So we need to pass this employee type in a square brackets, and we need to have one query to retrieve employee using ID, so called employee. And here we have an ID argument, And in this case, this ID of course would be not null because we need to have it in order to retrieve an employee. And now let's finish with mutations. And we have 3 mutations. The first one we'll call create employee. And we have here first name of type of string. And remember that this value should be not null. And the last name, also type of string and also not null. And it will return an employee type. Then we have remove employee. And here we have ID and string of string type, and of course this ID should not be null because we need to have an ID in order to return something, and it will return a boolean value. And finally we have an update employee, and here we need to pass ID. In this case we need to have ID because we need to distinguish which entity we want to modify. We will have a first name, a new value, and we have a last name, also not null, and we'll return an employee type here. So now we'll have this definition, and what I'd like to do next, I would like to start with an implementation of GraphQL server. But first let's check actually what we need to do in order to implement GraphQL with Vertex. So before we'll continue, let's just check what we need to implement in order to create a GraphQL server with Vertex. So first thing first, we need to define schemas for objects, queries, and mutations. So objects are basically models, and queries and mutations allows us to have same functionality like we do with CRUD method in REST API. So the second thing, we need to have a type definition registry instance, and this component allows us to have a bridge between schemas that we have defined and between Java code. So the third step is very important. We need to provide runtime wirings between queries, mutations, and business layer methods. So basically we need to make a connection between queries and mutations that we have defined in GraphQL and with corresponding business layer component methods. So the first step is to create a GraphQL schema from the registry and from runtime wiring component. So we use type definition registry from the step 2, and we use runtime wirings from the step number 3 in order to create this GraphQL schema. And finally we set up a GraphQL handler with a vertex router as the same way we do with all other handlers in the Vertex web library. So now let's start coding. Now let's start implementation of GraphQL components, and basically because GraphQL is just another way of implementing a web layer, what we could do, we could allocate all components that work with GraphQL inside the web package. So let's do it, and let's create another package, and let's call it web. So the first thing, I'd like to create a separate component that will isolate all GraphQL initialization logic inside. So we could just decompose it from the WebVerticle. So let's call it GraphQL manager, and let's make it a type of record. And I would like also to make it with a package private access modifier, because we actually will not access this component outside the web package. And here we need to pass two dependencies. The first one would be vertex instance, because we will actually use vertex file system in order to read this employees schema. And then we need to also to have employees service, because what we need to do, we need to provide wirings between a business layer and between queries and mutations used by GraphQL. And here we will have the only one method that will return a future, because actually we want to make it asynchronous. And let's call it GraphQL, get GraphQL. And what we will do now, we will return a vertex file system, because what we will do, we will read the file, and the path that we provide is relative to the resource folder. So we put here schemas employees.graphql, And then we need to map it because these methods will return a buffer, and we need to have a string representation. So first we use sequential composition in order to map this result to string. So we say here result to string, and then we'll start with a definition of GraphQL components. And the first thing first, we need to create a schema parser. So what we do here, we create a new schema parser, which is a component that allows us to have to be able to have a Java types representation of what we defined inside our schema. So we need to have a schema parser, and we also need to have a type definition registry, which basically a representation inside the Java code of what we have implemented inside our schema definition. And we could create it by calling parser parse, and as you could see, we could provide a file as the standard Java file as stream, like input stream, or schema as a string. And in our case, we have here a result as string, so we provide here a result. And finally, we return this registry to another sequential composition step. So the third step will have a registry here, and what we will do now, we will actually start with wirings, but we will not do wirings in this particular step. We will do it a little bit later, because I would like just to finish this pipeline first. But we need to have this runtime wiring component still. So we call it wiring, and it will be a null for now. So the first thing here is to create a schema generator, and we call it new schema generator, and then we create a GraphQL schema component, and we use this schema generator, and we use type definition registry that we provided from the previous step, and runtime wirings. And now we could return this GraphQL by using new GraphQL static factory method, so new GraphQL, and we pass here this GraphQL schema, and finally we use the build method. So now we have this whole GraphQL implementation, but as you could see, we still need to provide runtime wirings. So let's see how we could wire between business layer component and between GraphQL using this GraphQL library. Okay, once you go to the Vert.x web GraphQL documentation and scroll down to the fetching data section, you could see that there are different types of data fetchers. And the first data fetcher, which is a standard for GraphQL library, which is called a data fetcher, the disadvantage of this component is it's implemented with regard of sequential or synchronous programming. So as we do in sequential programming, we have a list of commands and we return a type. The problem is that it is oriented for synchronous programming, and when it comes to asynchronous programming, like we have a Vert.x ecosystem, we actually need to use another component that is called a Vert.x data fetcher. So a Vert.x data fetcher is built and it is a part of a Vert.x GraphQL library, and it is built with the vision of using it inside asynchronous programming pipelines. And the first type of Vert.x data fetcher, as you could see here, is the one that is used with callback based APIs. So callbacks are basically an approach that was used in Vert.x 3, and it's still legit in Vert.x 4, but it is a better approach to use the Vert.x futures. And in order to use Vert.x data fetcher with futures, all what we need to use this Vert.x data fetcher class and use this create static method, and then we will have access to this data fetching environment that allows us to communicate with data from GraphQL. So we could fetch arguments, for example, and use them inside our service layer. And as you could see that this Vert.x data fetcher component will wrap the type that would be later returned to the user. So in our case it will be employee, and we also use this Vert.x data fetchers with runtime wirings in order to build a bridge between schemas. So in our case, you could see here we have a query, and between your service layer. So let's see how we could implement it in practice. So go back to IntelliJ IDEA and let's create a first vertex data fetcher, and it will return an employee, and I will call it create employee. So this would be a mutation, so we use this vertex data fetcher create static method, and we'll have an access to environment. So what we could do now, we could get an access to the first name by using env get argument, and we have here first name, a name of the field, and the second one would be a last name. So we have here another argument coming from GraphQL, and then let's create an employee instance, and the ID would be null because it will be provided by data layer. Then we pass a first name and a last name. So now we could return our service, and we call this create employee method, and we pass here this this instance that was constructed. So basically logic is in some way similar on what we have with REST API and Vertex, but there we have a routing context, and we have data from let's say from query parameters or from body. We construct something, some entity, and then we make a bridge between a web layer and between a service layer. So in order to finish it, we need to make an equivalent of routing, because as you remember, in Vertex Web we have a router that allows us to distinguish between different paths, and here we have runtime wirings. So for now it is null, but we could use runtime wiring, new runtime wiring builder in order to incorporate this data feature. So the first is to provide a build here method, and we use this type method that allows us to pass a type name. So the type name here, if we go back to the definition of our schema, it will be a name of a query or a mutation that we use. So the first thing first, we have here a mutation, and we use this builder that allows us to specify data feature for each and every mutation and query that we have. So the first mutation we called create employee, and we pass here this create employee that we have already created. So likewise we could continue with other mutations. So we have here update employee, so it will be implemented with the same logic. So we have here our first name, we have here last name, but if we will go back to the definition of this schema, you could see that update employee also have an ID, and here we have ID type of string, but in our model it's actually a UID, so we need to make a parsing first. So we have here UID ID, and we call UID from string, and we pass here argument from the GraphQL. So now we create employee instance, we pass here ID, first name and last name, and we return service update employee. So likewise we need to register this runtime wiring. So we pass here a builder that allows us to specify data fetcher for update employee mutation. So, and the last mutation that we have here in the list is called remove employee. So let's provide its data fetcher as well. So the difference between our service layer, if we go to the employee service contract, is that we have here a void value, but in our schema we have here a boolean. So we need to have a mapping as well before we will return a type. So here we have a boolean, and we create here a data fetcher. So we will return here service, remove employee, and we need to have a mapping. So we return boolean true, because it will indicate that we don't have any errors. So let's provide the final mutation. And let's name it remove employee. And let's specify this remove employee data fetcher. So we need also to have here data fetcher first. So this is about mutations, and let's see how we could also do same thing with queries. In our schema we have two queries. The first one will return a list of all employees in the database, and the second will allow us to retrieve a single employee by its ID. So the process of an implementation of runtime wirings for queries is not different from mutations. So let's implement two remaining runtime wirings and data fetchers. So let's create another vertex data fetcher instance, and it will wrap an optional with employee as an internal type, and we call it find employee by ID. And here we have an access to environment, and what we have here an access to ID. So we could use this the same approach as we did in remove employee. So we have here an argument, and then we return a service, find employee by ID, and we pass here an ID. So in our case it is called employee. So let's go back to the GraphQL manager.java, and let's provide a type definition here. So first thing first, we have here query, which is a type of a type that we use here, and then we use a builder in the same way we did before in order to register a data fetcher for the employee query, and we have here find employee by ID, and the last remaining one, which is called find all employees, will return a list of employees. So not like we have here employee list, we will just return a list of entities. So in this way we need to provide a mapping. So we call it find all employees, and we create it using a vertex data fetcher. And what we will do now, we will return a service, find all employees, and then we do mapping. So we have here result, and we will return result employees. So this is the way we actually do mapping. So then let's just register the remaining query. So here we have a builder, and it's called all employees, and we pass here find all employees methods. So this is the way we do runtime wirings. So now we have everything initialized in this GraphQL manager component, and we could use it inside the WebVerticle. So now let's create a WebVerticle that will use a GraphQL. The last step that we need to complete is to provide an implementation of the WebVerticle component. So let's do it now. Inside the web package, what we need to do, we need to create a WebVerticle in the way that is familiar to us when we work with web applications using Vertex. So the same way we need to extend an abstract vertical. And what I'd like to do here, I would like to provide a class field, which would be an employee service dependency. So now let's create a constructor in order to obtain it using constructor-based dependency injection. And let's initialize it. So now we're ready to use, we're ready to create a start method implementation, and we use one with a promise argument because we use this promise in order to indicate to Vertex was this vertical successfully deployed or not. So the first step here is to create an instance of GraphQL manager, and we need to pass here two dependencies. The first one would be a Vertex instance, which actually a part of this vertical, because we use here abstract vertical parent class, and then we provide also a service dependency. So now we use here this get GraphQL method, and then we use sequential composition pipeline in order to initialize a router, initialize a server, deploy the server, and finally to deploy this vertical. So let's get this GraphQL, and like we always do, we start with creating handlers. So let's create a GraphQL handler, and we do it in the same way like we do with all handlers in the Vert.x web. So we use a static factory create methods. So a GraphQL handler has this method that allows us to supply this GraphQL instance. And I would like also to create another handler which will be called GraphiQL handler, and this handler allows us to use a GraphiQL web-based IDE, which basically a client that is used inside the browser, and it allows us to test our GraphQL API. So let's create another handler, and we use here GraphiQL handler create, and here we need to pass options, and basically we need to pass only one GraphQL handler option, which is called enabled, and we want to pass true value here. So let's see how we could do it. So we have here new GraphQL handler options, and we set here enabled as true because we want to set this handler to be enabled. So now, like we're always doing, we need to create a router. So we use here router static method, and we pass here vertex. And like we always do with Vert.x web, we need just to register routers. But remember that first thing first, we need to register a body handler. Because as you remember, GraphQL is basically a way we send post requests. So we need to be able to access this request body, and in order to do this, we need to have here a body handler. So now let's register routes. So let's register the first one would be called GraphQL. So, and for this endpoint, we need to specify a GraphQL handler. And I also would like to specify one for GraphiQL. And the difference here, we need to provide also the wildcard for requests that started with a GraphiQL, because we need to also to send requests. So here we have here GraphiQL handler, and now we create a HTTP server. So we use Vertex to create HTTP server. We specify request handler, and then we listen for the port 8080, and this basically is the way we could return. Because we have here router, not a server. So now we specify on failure handler, and we specify on success. And now we have a complete implementation of our WebVerticle. The last thing, we need to provide a main method. So we will use this main method in order to deploy and run our vertical. So here we create a new employee repository first, and then we create new employee service. And now we could create a new WebVerticle. And remember, as it's how it works in the Vert.x, once we create an instance of the vertical, you need to remember that once we have created an instance of the vertical, it doesn't mean that it actually was deployed and run. So this code is not executed until we actually deploy the vertical using a vertex instance. So we have here deploy vertical, and we use here on failure handler, and we print stack trace, and we also have on success handler. So now we are ready to run our code and test it. So let's see how we could use this GraphiQL in order to execute some requests. Okay, let's just play around with this sandbox application in order to check that our implementation is actually running correctly. So let's remove this comment code and let's execute some queries. So the first query that I would like to execute would call all employees. And remember, in GraphQL we could specify fields that we would like to output. So let's output the first name, last name, and ID. So let's execute this query, and now you see we have here all employees that we have. So now let me use this one. So what we will do, we will create another query, and it's called employee. So this will be a query that accepts ID. So we have here an ID. And remember, we could specify here fields that we would like to output. So we could have first name and the last name, and it will be a Vert.x. So let's execute this query. And okay, so this was Vert.x, so it was correctly performed. But let's just execute a query for the employer with IDs that we don't have in our database. So let's remove here the C and let's make here a B, and let's execute it. So now you see that Vertex is smart enough to understand that we don't have here an employer, and remember, we return an optional type here, so we don't have here a validation like we do on a web layer as we usually do with optionals. So we just pass an optional, and Vertex data fetcher automatically checks that we have a null value here. So let's now create some mutations. So let's create a mutation, and the first mutation I'd like to create is called create employee. And remember, we need to specify here a first name. Let's say it would be Yuri, last name, and I would like to return an ID. So now let me execute this this mutation. It was successfully executed, so let me comment out it and let me check for all employees. So now you see that I have this employer in the database. So let me remove this Vert.x, and we could remove entities by using a remove employee mutation. So let's create another mutation, and we'll call remove employee, and we specify ID here. So let me execute this mutation, and just pay attention that we don't have here any kind of return type, because actually we have just a boolean value, so we could not decompose boolean like we do with objects. So we could decompose objects on IDs, first name, last names, etc., but we could not decompose a boolean, so we don't have here any return type. So now let me just again need to execute this all employees, and you see that we don't have any of this Oxby item. So let's just take the first one. This is the first one, and let's perform update operation. So we create a new mutation. I call it update employer. We specify ID. So we specify this ID. We specify a new last name, would be called Branker updated, and the first name would be a star updated. And then remember, we need to provide fields that we would like to return. So say we want to return ID, and let's execute this query. And once we execute again all employees, you see that this value was updated. So this is how we could play around with the GraphiQL interactive client, and how we could play around with different endpoints. So this is a very naive way of testing, and of course you could not do it you couldn't do this testing like always when you just do some modification. What is more preferable way is to implement automated API tests. And how we could do it? Well, we will see it in the next episode of this series, how we could write API tests for GraphQL endpoints and Vertex. So don't forget to subscribe to my channel and to share this video with your colleagues, especially if this video was helpful for your job. So see you soon.